In this video, we are going to discuss implicit differentiation. This is the last of the tools you will learn to take derivatives, and with this tool and the others you've already learned, you can pretty much take the derivative of most functions that you're going to encounter. So first we need to talk about explicit and implicit forms of functions. So everything we've done so far defines functions with y as a dependent variable and x as an independent variable. For example, y equals f of x equals 2x plus 3. This is called the explicit form of a function, and it's explicit because you have explicitly written y as a function of x, right? You can solve for y on the left-hand side of the equation and all of the x's, and there are no y's on the right-hand side. There are also equations which cannot be written explicitly. For example, x squared y to the fifth minus 2xy plus 3 equals 0 cannot be written explicitly. That means you cannot write y equals some function of x. So this is called the implicit form. You can't write y equals some function of x, but if you knew what x was, let's say x were 1, then we would have an equation y to the fifth minus y plus 3 equals 0. And in theory, although perhaps not in practice, but in theory, we could solve that. We could find what values of y solve this equation. So this is an implicit form because we can't write it y equals a function of x, but we know that y is the dependent variable and x is the independent variable, just like we had it before. So y is dependent and it depends on x, the independent variable. We have explicit form where we can write y as a function of x explicitly, and we've got an implicit form in which we cannot write y as a function of x. We cannot write this, but we still know that if we plug in an x value, we can solve for y. And of course, there are some x values for which there are no solutions for y. But again, this is called implicit form. Now, we can use the chain rule to differentiate implicit equations. When we differentiate y, we get y prime, the derivative of y. When we differentiate x, it's just the independent variable, and we've always differentiated that. So basically, we can use this technique, implicit differentiation, and knowing the derivative of y is y prime, to find the derivative. And basically the technique involves taking the derivative implicitly, and then we will have y prime in several terms, and then we'll have to solve for y prime. So let's see how this works. So x squared minus 5y minus 1 equals 0. And this function, of course, we could write explicitly. In fact, let's do that over here so we can see the answer done explicitly and see the answer done implicitly. So let's see, we've got 5y equals x squared minus 1, y equals 1/5 x squared minus 1/5, which means that y prime equals 2/5 x. All right, let's do this implicitly. So we know what the right answer is supposed to be, so let's do this implicitly. We differentiate x squared, that's just a 2x. We differentiate y, well, we reduce the exponent by 1, bring it down in front, so 1 times y to the 0, so we have minus 5. But again, when we take a derivative of y, we end up with a y prime. Derivative of 1 is 0, so 2x minus 5y prime equals 0. 5y prime equals 2x. Y prime equals 2/5 x. Exactly the same answer as we did. All right, let's do another one. So we have x squared minus 5xy squared minus 1 equals 0. So this is a lot more complicated. Let's see, the derivative of this first term is 2x. The derivative of the second term, let's put a little multiplication sign in here. We're doing a product rule. 5x is the first function, y squared is the second function. It's a product rule. We take the derivative of the first function, so that's going to be minus 5 times the second function, y squared, minus the first function times the derivative of the second function. That's 2y to the first times y prime. That's the chain rule. minus 1. The derivative of 1 is 0, so that's equal to 0. Now we need to solve for y prime. So we're going to isolate y prime on one side. So we'll do it here. So that's going to be 5x. Oop, that's not 5x. That's going to be, let's scratch that out. Okay, let's do it again. Let's do it all over here. So we're going to have 10x y prime equals, so we brought that over to the other side, 2x minus 5y squared. 2x minus 5y squared. We want to find y prime, so we take y prime equals 2x minus 5y squared, all divided by 10xy. So there's our derivative. Notice it's got x's and y's in it. X squared ln y plus y equals 0. Again, we've got a product rule here. We'll explicitly put our multiplication sign in there. Derivative of the first function, so that's 2x ln y plus x squared, first function, times the derivative of the second function, that's 1 over y, times the derivative of y, which is y prime, plus y prime equals 0. So we'll leave all the y prime terms. You can see there are two of them on the left, and we'll put the other term on the right. So we're going to get, let's factor out a y prime. So we get y prime times x squared over y, make that a little bigger, x squared over y plus 1 equals negative 2x ln y, which means that y prime equals negative 2x ln y divided by x squared over y plus 1. Again, notice that both there are x's and y's on the right-hand side. We've got the y prime on the left. And this always works. The y prime, because of the chain rule, right? Here we took a derivative of ln y, dx, we're taking a derivative with respect to x, of ln y equals 1 over y times y prime, derivative of y. Okay? Next problems. X squared 10 to the y minus 1. Again, same thing. We've got a product rule here. 2x, derivative of the first function, times 10 to the y. Be careful, you can't bring that 2 in there. Plus x squared, derivative of 10 to the y is 10 to the y ln 10 times y prime equals 0. And then we solve for y prime. I'll do it over here. So y prime equals, bring the 2x 10 to the y over to the right-hand side. So it's a negative 2x 10 to the y divided by, and then we've got a y prime here, so it's going to be x squared 10 to the y ln of 10. So again, it's all about being careful. In order to solve these, not only do you have to take the derivatives, but you're going to have to do some algebra as well. E to the y times x equals 1. All right, e to the y times x equals 1. Derivative of the first function is going to be e to the y times y prime times x plus e to the y times derivative of x is 1 equals derivative of 1 is 0. Solve for y prime. So we've got e to the y prime times x equals negative e to the y, which means that, let's put it over here, y prime equals negative e to the y divided by x e to the y, which is negative 1 over x. And that's it, right? Negative 1 over x. So, could we have done this differently? Of course. We could have written this function explicitly by doing e to the y equals 1 over x. Take the natural log of both sides and we get y equals natural log 1 over x. So y equals negative ln of x, right? 1 over x is x to the minus 1. We can bring the minus 1 out in front. Y equals negative ln of x. Y prime equals negative 1 over x. Y prime equals negative 1 over x. Last one, x squared ln y plus y equals 0. Derivative of the first function, 2x ln y plus x squared over y, y prime plus y prime equals 0. Factor out. Y prime times x squared over y plus 1 equals negative 2x ln y, which means y prime equals negative 2x ln y divided by x squared over y plus 1. So it's just a matter of being careful with the algebra to solve for y prime. Ln of xy equals 2. Okay, so this derivative requires a chain rule, and then it's going to require a product rule after that. So the outer function's ln natural log, so we get a 1 over the inside function, xy, times the derivative of the inside function, which is going to require a product rule. Derivative of x is 1, so 1 times y plus x times y prime equals 0. Let's multiply through. So y over xy is 1 over x plus y prime over y equals 0. Implies y prime over y equals 1 over x, negative 1 over x, sorry. Implies y prime equals negative y over x. All right, next. Square root of x plus y equals y. Again, we have a chain rule here, and then we're going to have a chain rule over the implicit differentiation to get the y, derivative of y. Okay, so square root of x plus y. 1 half x plus y to the negative 1 half times derivative of the inside function, 1 plus y prime, equals y prime. We need to get all the y prime terms on one side and get the other terms on the other side. So what do we have? We've got a 1 half x plus y to the negative 1 half equals y prime times 1 minus, right, this is this term, 1 half x plus y to the negative 1 half, which means that y prime equals 1 half x plus y to the negative 1 half divided by 1 minus 1 half x plus y to the negative 1 half. Now, of course, you could do a little bit of simplification, multiply top and bottom by, say, x plus y to the half, and we'll get rid of some of these negative exponents, but we don't need to. All right, e to the y equals x. Well, that's e to the y times y prime equals 1. Y prime equals 1 divided by e to the y equals 1 over x. Remember, e to the y equals x. Which, again, this is the same trick we did before. If we took the natural log of both sides, we would get y equals ln of x, which means y prime equals 1 over x. So get the same answer.